Hello guys, welcome to our class for today. This is Number My Science Tutors Online and I'm Notable Michael. For our class for physics today, we'll be looking at conservation of linear momentum and Newton's third law of motion. So please get yourself ready, get your writing materials so that we can go straight to our class. You can reach us through the WhatsApp number that is showing on your screen. And if you have not subscribed to this channel, please subscribe to this channel. Click on the notification button so that whenever we upload a new video, YouTube will notify you. Is that okay? Also invite your friends so that they can come and enjoy this physics class that you are enjoying online. Give us a thumbs up, give us a like, place your comment on the comment section below. We'll look at your comments and then we'll continue to improve as we progress in this online physics class. So get your writing materials ready so that we can move straight to the class. Conservation of linear momentum and Newton's third law of motion. So what is the statement of Newton's third law of motion? Newton's third law of motion states that for every action, there is an equal and opposite reaction, right? So every action has an equal and opposite reaction. And from this law and the second law of Newton, we have the law of conservation of linear momentum, or the principle of conservation of linear momentum. And this principle states that if two or more bodies collide in a closed system, the total momentum after collision is equal to the total momentum before collision. Or you can say the total momentum before collision is equal to the total momentum after collision. Now, when you say a system is closed, it means that in that system, there's no external force that is acting. So a closed system is a system on which there's no external force acting. Is that okay? No external forces are acting on the system. So we say the system is closed, right? So from this principle of linear momentum, if we have two bodies of mass A and B, just assuming we have two bodies of mass A and B, and each of them they are moving with velocities u, a, and ub respectively, we know that when we stated the law and the equation of momentum, we said that momentum is equals to mass times velocity. So for each of the bodies, their momentum before collision will be ma times ua, and then the one for b will be mb times ub. Okay, so according to the principle of conservation of linear momentum, if the two bodies collide, okay, if they collide, their total momentum before collision will be equal to their total momentum after collision, because their final velocities will be va and vb. So their momentum, their final momentums each will be ma times va and mb times vb. So the law of conservation of momentum says that this momentum before collision is equal to the momentum after collision, taking the two together. Okay, so this is the principle of conservation of linear momentum, right? So we are going to derive the equations that are applicable. Equations of conservation of linear momentum. We said that if you consider two bodies A and B of mass A and with initial velocity UA, and then of mass B with initial velocity UB, their total momentum before collision will be MA UA plus MB UB. Okay, then their total momentum after collision they will move with their own final velocities. So their total momentum after collision will be MAVA plus MBVB. So taking the two together, considering the principle of total linear of conservation of linear momentum, we will now have that their momentum before collision, their total momentum before collision is equals to their total momentum after collision. Okay, so this is the statements of the law or the principle of linear momentum, and this equation applies as we are going to consider them. This equation applies, so take note of that. Okay, so based on that our discussion on conservation of linear momentum, we now consider different types of collision. So we have two types of collision. We have elastic and inelastic collision. You know, when object moves in a closed system, they can collide with one another. Now when they collide, the way they move out will depend if their collision is elastic or inelastic. Sometimes when they collide, they will move out with their separate velocities, or when they collide, they can stick together and move with a common velocity. So these are the two scenarios that we have when object collides. Okay, so for elastic collision, right, in this collision, the two bodies will collide and move out with their own velocities. Okay, the two bodies, so assuming we have two bodies A and B with initial velocities UA and UB, when they collide, they will move out with their own final velocities. This type of collision is known as elastic collision. Elastic collision. Now in this collision, the total kinetic energy and their momentum is conserved. That is, no energy, kinetic energy is not lost, total momentum is not lost. Their total kinetic energy of the colliding bodies and that of their momentum is conserved. So the total momentum and kinetic energy before collision, because the kinetic energy and the momentum are conserved, their total kinetic energy and momentum before collision is equal to the total kinetic energy and momentum after collision. Is that okay? Sorry about that. So the two bodies will move separately after collision. So you have a typical example of gas molecules in a container, right? The gas molecules in the containers, they will continue to move continuously, so they collide with one another and they move out with their separate velocities. So this is a typical example of elastic collision. So as an example of elastic collision, we have collision of molecules and atoms in a container. Molecules and atoms in a container, they collide with one another, they move out with their separate velocities. So mathematically stated, we say that based on the equation that we derived before, that momentum before collision is equal to momentum after collision. So take note of this equation, right? Momentum before collision, that's MAUA plus MBUB, is equal to MAVA plus MBVB. So this is the equation for elastic collision. Now you also want to know that if the two bodies, if A and B, they are traveling in opposite direction, right? So the sign for the B will be negative. So the momentum before collision will be MAUA minus MBUB, and when they have collided, you have MEVA plus MBVB. So when they are moving in opposite direction, this is the equation that applies. Then for their total kinetic energy, we said that for elastic collision, the total kinetic energy remains the same. So the total kinetic energy before collision is equal to the total kinetic energy after collision. So that's what we have here, the kinetic energy of A and B the sum of their kinetic energy is equals to the sum of their kinetic energy after collision. Okay, so please take note of these equations, because if you are able to apply this equation, there is no problem on momentum that you will not be able to solve. Okay. Okay, so this is the second type of collision. We said that there are two types of collision. One, the bodies collide and they move out with their separate final velocities. So in this inelastic collision, the two bodies, they will collide and they will stick together and move out with a common velocity v. So if we consider those two bodies again, A and B, right, their momentum before collision will be MAUA plus MBUB. Now after they collided, they stick together. So you add their total masses together, then multiply by their common velocity. Is that okay? So in this type of collision, kinetic energy is not conserved, but momentum is conserved. That is the difference between the two. In this type of collision, kinetic energy is lost, but momentum remains the same. Momentum is conserved. So kinetic energy is lost and the two bodies stick together and move with a common velocity v, but their total momentum is conserved. Alright, their momentum is conserved. Then if the two bodies are moving in opposite direction, their their momentum before collision will be, because they are moving in opposite direction, the momentum will be, this is the equation that will apply. The MAUA minus MBUB is equals to MA plus MB, all bracket multiplied by their common velocities. Then their kinetic energies, this is now will be the equation for their kinetic energies. Kinetic energy before collision is equals to their common kinetic energy. Now you will see that if you look at this equation, you discover that the kinetic energy before collision is greater than the kinetic energy after collision. So that is why we say that in this type of collision, kinetic energy is lost, but momentum is conserved. So take note of these equations, because these are what we'll use to solve some problems. Right? So these are the equations for the different types of collision that we have. So these are the summary of the equations that we just discussed. So when you consider the two bodies that we talked about, A and B, their momentum before collision is MAUA plus MBUB, and their momentum after collision is MAVA, because V is their final velocities, and MBVB. So from what we discussed, we said that from the law of conservation of linear momentum, their total momentum before collision is equal to their total momentum after collision, right? Then for elastic collision, we said that when the two bodies collide, they will move out with their separate velocities. So momentum before collision is equals to momentum after collision, right? Then when they are moving in opposite direction, this will be their momentum before collision, and then this will be their momentum after collision. Their kinetic energies is the kinetic, and the sum of the kinetic energy before collision is equal to the sum of the kinetic energy after collision. For elastic collision, the two bodies, they will collide and stick together and move out with a common velocity v. So momentum before collision is MA plus MAUA plus MBUB equals to MA plus MB, because the two bodies, they stick together times their common velocities. Then when we're moving in the opposite direction, this is their momentum before collision, then momentum after collision. their kinetic energies are given with this equation too, right? So these are the equations that we just discussed. Please take note of these equations as we go straight to solve some problems relating to all these equations that we have discussed. So this is a sample question that I want to consider first. This question states that a bullet of mass 0.05 kg is fired horizontally into a 10 kg block which is free to move. If both bullet and the block move with velocity of 0.5 meters per second after the impact, find the velocity with which the bullet hits the block. So when you look at this question, the bullet has a mass of 0.5 kg, the block has a mass of 10 kg. But if you look at the question very well, you see that the bullet is moving while the block is stationary. So if you consider that the initial velocity for the block will be equals to 0, but that of the bullet is what we are looking for. And you said that when the bullet hit the block, both of them move together with a common velocity of 0.5 meters per second. So this question depicts which of the collision. So the collision that this question depicts is inelastic collision. Okay, so once you can able to do that simple analysis, you can bring out the information that you are giving. Okay, so you can say this is MB, which is mass of bullets that's given to you. Okay, mass of bullets is 0.5 kg. Initial velocity of bullets is what we don't know. It's what they're asking you to look for. Mass of block. Okay, so mass of block, we can give it another sign. So M2 is equals to 10 kg. That's what is given to you. And then from the question, the initial velocity of the block is equals to 0. Then their common velocities v after collision is given to us to be 0.5 meters per seconds. So guys, once you are able to bring that out, the equation is ready to solve. Now according to the law of conservation of linear momentum, we have that okay, momentum of bullets plus momentum of block is equals to their masses together, the sum of their masses multiplied by their common velocities v. Okay, so this is a statement of the conservation of linear momentum for this particular question. So having done this, you can now impute the information that you have. Okay, so this you now have that 0.05 multiplied by the velocity of the bullets plus this. The velocity of the block we said is 0 because it is stationary or it is at rest. Then you now add their masses and multiply by their common velocities. Okay, so you have 0.05 multiply by 10 kg, add to 10 kg, multiply by 0.5 meters per second. So when you work this out, this will be 0. 10 times 0 is 0. The mass of the block is 0. Okay, so this is what we're looking for, UB. So we have 0.05 VB, velocity of bullet, equals to the 10 plus 0.05, we have 10.05 times the common velocity, which is 0.5. Okay, so when you do this multiplication, it will give you 0.05 VB equals to 5.025. So you can now make your VB the subject of the formula, or divide both sides by 0.05. If you divide both sides by 0.05, okay, alright, so this will cancel out, and then this will now give us equals to 100.5 meters per second. So the initial velocity UB, the initial velocity for the bullet now, which is UB, is equals to 100.5 meters per second. Okay, so you can see how we analyze the problem from stating the law of conservation of linear momentum for this particular problem, which we understood to be elastic collision. Then how we applied it, we see that the block is at rest, so the initial velocity of the block is 0. It is the bullet that was moving, so, and that is the velocity that we are looking for. So their momentum before collision is this, and the momentum after collision is this, according to the law of conservation of linear momentum. And then we imputed our values, and we arrived at this conclusion as the answer. Is that okay? So I hope this is simple and it's easy for you to follow through. This is another sample problem that I want us to consider. So another sample problem that I want us to consider. Okay, so in this problem there are options. It's a jam question actually, so there are options. The driver of a motor car of total mass 800 kg and which is traveling at 20 meters per second suddenly observe a stationary dog in its path 50 meters ahead. If the car brakes can exert a force of 2000 Newton, what will most likely happen? This is a jam question, so we'll look at the question and then do the analysis and then solve this question as the case may be. So first and foremost, we have the mass of the car. We are told that the car is traveling at the speed of 20 meters per second. Then we have a dog that is stationary 50 meters ahead of the car, and then the brakes are applied with a force of 2000 Newton. Alright, so we will be given mass of car. Mass of car is given to us to be 800 kg. The velocity of the car is given to us to be, or the speed is given to us to be 20 meters per second. 20 meters per second. Then the braking force of the car is 2000 Newton. That's the braking force of the car, 2000 Newton. So we'll be focusing on this information that are given to us to solve this problem. So what will most likely happen. Now from this variable that we have, since the car is moving and then it applied this braking force, we can find from this, we can find the acceleration or the retardation of the car, because the car will be coming to rest. So we can find the acceleration from force. First of all, finding the acceleration, force equals to ma. Okay, and a is equals to f over m. So put in your values. We have 2000 divided by 800 to get the acceleration of this car. So if you do that division out, you'll see that your acceleration will be equals to 2.5 meters per second squared. 2.5 meters per second squared. This is your acceleration. Now, having gotten your acceleration, the other thing you will not be looking for is the distance traveled before the car came to rest. You know, once you step on the brake, the car will begin to decelerate until it comes to rest, right? So which means that because the car is coming to rest, the final velocity of the car will be equal to 0. So we want to know the distance it will travel before it will come to rest. Final velocity is 0. The velocity that the car is used to travel is 20 meters per second. Okay, so that is the initial velocity of travel. Then the final velocity, because the car is coming to rest, will be equal to 0. So you apply the third law of linear motion to that equation. So v squared is equals to u squared plus 2as. We say final velocity is equals to 0, so that part of it becomes 0. Okay, so now you have you write the equation. You have u squared is equals to 2as. Note that we are looking for s. So s, if you make s the subject, will be equals to u squared all over 2a. U squared over 2a. So if you impute your values here, u is 20, a is 2.5. So u will be 20, u squared will be 20 times 20 all over what? 2 times acceleration. So by the time you work this out, you are going to have 400 all over 5. So when you do that division, you will have what? You have that the distance traveled by the car before coming to rest will be equals to what? 80 meters. Okay, so this is the distance traveled by the car. Look at where the dog is standing. The dog is standing 50 meters ahead of the car. Now when the brakes are applied, the car stops at 80 meters. So the difference between the distance of the dog and that of the car, you calculate it. Say 80 meters for the car minus 50 meters for the dog, which equals to 30 meters. Okay, so which means that this car, the car will stop after it has passed this 50 meters where the dog is standing. So invariably you see that the car will, it means that the car will stop 30 meters after hitting the dog. the car will stop 30 meters after hitting the dog. Is that okay? From what we have calculated, it means that the car will stop 30 meters after hitting the dog, and that gives you this option B as the correct answer. The car will stop 30 meters after hitting the dog because it will stop at 80 meters after the application of the brake, and the dog is standing at 50 meters ahead. So the difference in their distances is 30 meters. So the car will stop 30 meters after hitting the dog. So see the analysis of this question, how we are able to relate equation of force to the third equation of linear motion, and then we arrive at this answer. Is that okay? So all these equations, they are related. You need to take note of them. All right. So this is your test your understanding page. Please solve all these questions. You can snap your answer, put it on the WhatsApp number that is showing on your screen. Is that okay? Just add up that number, then it will take you to our WhatsApp chat page, or the link is in the comment section. The link is down below in this video, so you can check the WhatsApp link, click on it, it will take you straight to the WhatsApp chat group where you can paste your answers there. Okay, so this is where we are stopping for our class today. Solve all this problem and then paste your answer. Right, this one says that a body of mass, a body P of mass 5 kg moves to a velocity v collide with another body Q moving in opposite direction with a velocity of this. So remember that equation for the conservation of momentum when the bodies are moving in opposite direction. There is one, an arrow of mass 0.53 kg is fired with a velocity of this 100 meters per second into a wooden block of mass 0.5 kg. Alright, so 0.7 kg. Calculate their final kinetic energy after impact. So this block, you know that it is stationary, so know the equation to use. So what change in velocity will be produced on a body of mass 4 kg if a constant force of 16 Newton acts on it for 2 seconds? When taking a penalty kick, a footballer applies a force of 30 Newton for a period of 0.05 seconds. If the mass of the ball is 0.075 kg, calculate the speed with which the ball moves off. Okay, so know the equation to use and then solve all these problems. So this is where we are ending our class for today. Thank you so much for listening, and if you have not subscribed to our channel, please subscribe to the channel, click on the notification button, and also give us a like, give us a thumbs up. We promise to continue to give you quality physics lectures. Is that okay? Also invite your friends to come and join this channel. You can reach us through the WhatsApp number that is showing on your screen. So this is Normal Mind Science Tutors Online, and we are going to see you in our next class.